Hello, my name is Elena Jordan. In this presentation, we'll be going over Lab 4, Combustion Dynamics in a Rikje Tube. This experiment was performed at the Georgia Institute of Technology through the Aerospace Engineering undergraduate program. So what is a Rikje Tube? A Rikje Tube is a type of pulse combustor, which is a natural gas burner characterized by periodic combustion processes. The Rikje tube, which is named after its Dutch inventor, consists of a very long, narrow, vertical tube open at both ends with a source of heat at the base, as you can see by the diagram on the right. The purpose and goals of this experiment are to understand what happens and why it occurs in Rikje tubes. The experimental setup used, shown by the diagram on the right, consists of 3 narrow tubes with piezoelectric pressure transducers attached to them. This is to measure the pressure values given at different heights of the Rikje tube. The photomultiplier tube is used to measure the wavelengths emitted in our specific range for this experiment. Also, a rotometer is used to measure the mass flow rate. As you can hear, the flame creates a resonance frequency. This is due to multiple characteristics of the Rikje tube. The data was taken at multiple trials of this experiment using a scissor jack to raise the combustion in order to analyze how height changes this resonance frequency and different properties of it. It was first taken, trial 1, at the base position, 0 inches raised, with the valve closed. Then it was taken 0 inches with it open. This allows us to see different characteristics, such as how the flame height grows when there's not a lot of pressure waves dampening it, leading to less of a sound generated by the different pressure waves bouncing off the tube, leading to resonance. Similar to like how an organ works, with the air flowing through the tube. We chose 5.2 inches with the valve closed because this is where the position of where the pulsation ceased for our experiment. Data reduction. This segment of the data reduction shows the RMS values for not only voltage but pressure. This was calculated through the use of different calibration charts, which were given in our lab manual. The voltage RMS was converted to millivolts, and then the conversion factor was found from the charts to translate it to pressure in PSI, as you can see in the bottom left chart. In the bottom right chart, the sound pressure level in decibels was calculated using an equation given to us in the lab manual. This is 20 log base 10 of the PRMS over the PRMS threshold, which is the threshold of human hearing, which is given to be about 2.9 times 10 to the negative 9 psi. This allowed us to find the sound pressure level in decibels for each trial at each different height, with PL being the pressure of the lower, PM being pressure of the middle, and PU being the pressure of the upper of the piezoelectric transducers. Data reduction frequency. For the different run numbers at the positions given, we listen for the resonance. As you can see, with the valve open, we didn't hear any resonance. And at 5.2 inches, even with it closed, we didn't hear any resonance. That's because, like I said, at 5.2, that's basically the cutoff for our experiment, as far as we can tell. We also worked to estimate the resonance frequency calculated. This is done using the speed of sound, which is given and calculated to be 1,127.7 feet per second, assuming a specific heat ratio of 1.4 and room temperature values. Then we could calculate resonance frequency by dividing this by 2 times the length of the Rikje tube, which is 5.875 feet. This gives us a resonance frequency of about 96 Hz. The peak frequency for each run can also be seen down below. It's very notable that run 2 with the valve open and run 4 at our cutoff are wildly different from runs 1 and 3. Data reduction relative phase. This shows the relative phase in degrees at the 0-inch burner location, both with the valve open and with it closed. You can see the associated phase as well as the relative phase, which is taken in association to the PL value. This shows us how added heat creates resonance in a Rikje tube, and the more heat is added, the more resonance you're going to get, but also it depends on the height and the valve of the Rikje tube. Also, we can see that moving the burner up the tube decreased the sound as well as opening the valve. And eventually, if you kept moving the burner up and up the tube, it will cease altogether. This experiment was very interesting to me because it was my first exposure to combustion dynamics and how different things that you wouldn't really think about can affect your experiment altogether, such as wind over the top of the Rikje tube, the height of the Rikje tube flame, etc.